Right. Good evening, everyone. I'm Ruchira from the Oceanography Division, NARA, with a coastal engineering background. I apologize for my physical oceanographic knowledge. With my colleague Udeshika from Marine Biological Division. First of all, I would like to thank Amit and the organizing committee for inviting me for this workshop and for the meeting. This happened last time because first my colleague supposed to attend the meeting, but unfortunately he couldn't. Therefore, I came here. Okay. Sri Lanka is located in very important geographically important place where the shipping routes near the shipping routes, and also it is crucial the Sri Lankan the circulations along the coast of Sri Lanka is crucial for the interaction among the Arabian Sea, Bay of Bengal, and the equatorial Indian Ocean. We understand the importance of contributing to the joint cruises. So we are working with international collaborations as well. We are trying to collect as many as data with our limited capacity. So my talk is about the recent experiences in ocean and coastal observation in Sri Lankan water. So these are the few joint expeditions the NARA combined with the international organizations. We worked with the RCD projects in 2013 and 2015. We had RV Roger Revelle, the joint cruise, and also last year RV Thomas for the monsoon intraseasonal oscillations. As well, we had Dr. Fridtjof Nansen, the Norwegian ship. So for that one, actually, the objective is to assess the fish stockman assessment in the Indian Ocean, in the Sri Lankan region. And also we had some joint cruises with the Indian naval ship Darshik. The objective of these cruise was to update the navigational charts in the southern Sri Lankan waters. And these are some snapshots what we did in the ocean with our small research vessel RV Samudrika. Right. And with RV Samudrika, we have collected two transects CTD data. One is from the east coast and one is from the south coast. The CTD profiling survey was conducted along these two transect. The purpose of this survey was to get salinity, temperature, and density profiles along the transect. Right. The circulation and hydrographic structure of the Sri Lankan shelf, slope, and the deep ocean were examined through the collaborations between NARA and US partners. Many of these observations are the first of their kind of this region. This is the south transect, and we would lucky to continue this data collection this year too. And this is the few slides I have taken from Professor Vijay Sekhara's paper. Actually, okay, this is actually from the Roger Revelle survey we did in 2015. And also right. And also we have contributed to collecting the tracks of Lagrangian drifters. These are some results of the track of 8 drifters deployed east of Sri Lanka between 25th October and 23rd December 2013. This shows the East Indian coastal currents. And this is the ocean observation centers around our country, and we have 3 sea level stations where we measure the sea level heights. The Colombo one is the long term. It is actually from 1960s, I think. And also we have the flux tower in Nara, and also weather station in Beruala and Kirinda were built during the RCD project. And with this figure shows the offshore wave climate, which is derived from ECMWF, European Center for Medium Range Weather Forecasting, and the data taken from ECMWF. This is ERA interim data between 1979 to 2012 from the southwest coast of Sri Lanka. During the northeast monsoon and southwest monsoon, and also the intermonsoons, and this shows southwest monsoon is dominant for the southwest coast of Sri Lanka, and during this season we experience a lot of coastal erosion stuff along this coastline. Okay, this is the wind climate, also from the ERA interim data for the same period. It shows both the southwest and northeast components of the winds. And also this shows wave power potential around Sri Lanka, and along the southwest coast of Sri Lanka, especially southern coast of Sri Lanka, we have potential wave harvest. And this shows D, E, F, and G, a comparatively larger wave energy, right? And now we have some programs in this region harvesting wave energy. Now it's going on with the help of Finland government. And this is the numerical modeling of spatial variation of sediment transport using the wave climate schematization method. This is actually this is Colombo port, and this is a 50 kilometers coastline. Colombo is the capital of Sri Lanka, and this is the Colombo port. And this area now we are developing the Colombo the port city project, and reclamation project is going on. And for this wave climate wave model, we have used ERA interim data from 1979 to 2015, but we schematize data using energy flux method, and the representative waves are taken for running the model. And this shows 3 different offshore wave. The result is from 3 different wave scenarios. And also you can see the diffraction from the Colombo port. The waves are changing due to the Colombo port, the breakwater. The breakwater itself 1.2 kilometers long. And this is the depth average velocity. the numerical model results. The problem is in this coastline we don't have much more measured data. Therefore, this is actually the data. The region is data poor environment, and so always we depend on the numerical models and the analysis data. However, we have calibrated the model with some available data, and actually this region is exposed to the swell wave, and comparing with the whole region, this region has more wave heights and also the depth average velocity, and the average velocity is reducing over this region. That's because of the Colombo breakwater, and also the milder slope, the profile and profile further weaken the wave heights and the depth average velocity here, but it takes somehow it again capture the velocity up to 0.3 meter per second. The depth average velocity over here is 0.3 meter per second. We use this model to predict the future scenarios. For example, we are going to build another project here. It is also a reclamation project, and we are going to have that one. And with using this model, we will try to figure out with that structures how the sediments and related coastal erosions going on in future. Right, and the sea level data also, we are collecting sea level data around Sri Lanka. These are the points we have collected sea levels, and this Trincomalee, Miris and Colombo is long-term sea level stations. And with available sea level data and available abysso data, we try to calculate the sea level rise in the locations where the tide data is available. And all the stations, the Garcia, Cocos, Cochin, Male, and the location shows more or less similar trend, except the Cochin and Colombo where the tide gauge data is less. With the available tide gauge data, this is the sea level rise. This shows the Colombo is very high, but I say this value is very high with comparing with the IPCC predictions. That's because we have to calibrate the tide gauge data with the, I think with the it's some let's say the vertical changes in the station settlements. And this is what the abysso shows. This is more or less same with the IPCC predictions. And in Male, we have more or less 3.8 millimeter per year the sea level rise, and Colombo is 1.8. And Cocos shows the highest one. It is around 4 millimeter per year. And this figure shows the shoreline variation along the southwest coast of Sri Lanka. Coastal erosion for different time spans. This is the long-term span and the short-term span. And with comparing with these two figures, we can say for short-term periods after 2005, we have a lot of erosions going on in this region. This is north of Colombo. That's maybe one reason is the coastal development and structures in Colombo, and another one is the extensive sand mining in the adjacent rivers. When the rivers doesn't give the sand to ocean, then the sediment budget is changing and the erosion is going on. These are few snapshots of the place where the erosion is going on. This is a long-term erosion map and the short-term erosion map. You can see with in this region, this is Colombo. The short-term erosion is going high. Okay, I will stop this one now. You can